Okay, hello and welcome to the Knox Makers Discrete ADC, analog to digital converter build instructional video. I'm going to walk you through how to build this kit and how to debug it and troubleshoot it if things don't look as expected. I'm not going to go through so much about how to solder and that kind of thing on this kit. We do cover that in a lot of our other kits. This is a little more of an advanced build and we're going to just skip over that part of it. So this is the final product, what it's going to look like. So hey, let's get started. So take your board and components, you can dump them out of the bag on your workspace. Try to be careful not to let any of the parts fall on the floor. The last thing you want is your errant mouse that's living in your house to grab components, build it into his nest in the back of your cabinet. All right, so it should have a bunch of LEDs in here. There's 3 integrated circuits. They might be in foam like this and maybe some other form factor in the particular kit you've got. Switch, this is a reference IC, potentiometer, and a few capacitors, right? So a few different components. Oh, and this big string of resistors, okay? So we usually build these kits starting with the lowest profile parts going up to the highest profile parts. In this case, we're going to start with these resistors. If you haven't done resistors like this very often, these are kind of inserted vertically. I can show you on this finished board. Helps reduce the amount of lateral spacings take up, so you do it just for form factor reasons. What I do is I take the body in one hand, just kind of bend the lead over. I always put the tolerance band, the gold band in this case, on the bottom. So if I had something with a lot of components down there, it's hard to see it. I kind of look with a flashlight or something, and if I see a few of the bands, I know if I'm looking, I know I can start placing the colors of the bands with a value resistor. All right. So I'm going to start by just putting all these resistors in here like this. And I'm probably going to see if I can't fast forward this video for you so you don't have to sit and watch me put all these in, but if not, you may need to hit fast forward yourself here. Okay, all of those vertical resistors appear to be mounted, so I'm going to move on to the horizontal resistors. We got 2, 4, 6, 8, 10, 12, 14, which are all used to bias the diodes, set the current through the diodes. I'm going to do those next. Looks like I need to bend the leads quite close to the body for these to fit nicely. Okay, I've got all these flat resistors now, horizontal resistors in place. So solder them in and move on to the next component. Okay, those look pretty good. I'm going to put these capacitors in next. These capacitors are each simply just bypass capacitors, supply bypass capacitors for these ICs. Probably have one of these on the entire board. You really don't need, I don't think for this kind of a circuit, these things this close to the ICs. I don't think anything's going to happen if you didn't, but it's sort of good practice, so it's an extra few cents. It's an extra couple components that are fun to solder, so we're just going to do it. Okay, we've got our capacitors in, we have all of our resistors in. Let's do some diodes next. So diodes, you do need to watch the orientation of them. The flat side of the diode, or the short lead of the diode, needs to be aligned on the side with the silkscreen bar, the silkscreen line, or it's also the square pad. So the diodes do need to be oriented properly or they will not light up. So measure twice, cut once, or as I say, orient twice, solder once, trim once, something like that. Okay, from here, I'm going to next do this U4 integrated circuit. You have to bend these leads out just a little on here for it to fit in the formed lead holes on the printed circuit board, just a touch probably. You don't have to shove it right down flush against the board, just get it, get it pretty close. That'll be fine. It does need to be oriented correctly. You can see there's a silkscreen outline on the printed circuit board. It has a flat on that outline and a curved portion. That needs to align with the shape of the case of this reference voltage. Okay, next I'm going to do this potentiometer. I like these little guys. It can only get oriented one way. If you look, the lead should fit nicely with one particular orientation. This sticks out of the board enough that the way I've assembled it, just resting the board like this will push the component against it pretty nicely. But you do want to make sure that part is kind of flush. Okay, I've got that guy. Now, I've got the switch. I'm going to do this switch next and do the integrated circuit, save the best for last. Switch is not quite as tall as the potentiometer that I put in. It's because of the order I put that in. The switch may not want to set flush when I solder it. So I'm going to show you a trick for that. If I come in here, the switch leads are pushing through the board, but it's not actually flush on the back side, I can tell. There's two options. One, I can just push down on the board. In this case, if I push down on the board, it's going to kind of tilt the board that way, and it's going to take care of getting it nice and flush. I'm going to try that first, see how that works. Got to hold it on here a little bit longer because this outside lead is attached to the metal housing of that switch. It worked just fine. If that didn't work, if I wasn't happy with that, I could then push down with my finger on the plastic portion of the switch. I could push down gently with that while I reflow this connection on the back. And if it wasn't nice and flush, once that side reflowed, I would then push it flush with my finger. But it was flush. Okay, so solder the rest of those leads. Now my switch is in place. Okay, so the only thing that's left at this point are the three integrated circuits. Now, there are two LM339s here and S74, SN148 or something here, the BCD coder. So it's a different part number. So if you look on these ICs, they are labeled there. You'll see LM339. And these two guys. This other one, if I can read it, a little hard for me to read. Maybe you can read under there now. SN74HC148, looks like. Now these, so the LM339s are going into U1 and U2 over here. These do have an orientation. You'll notice a little divot in the silk screen and that circuit board, and it aligns with a divot on this integrated circuit. Some ICs will have a circle here next to pin 1. And that would be, this would be pin 1 in this case. You can see on this board that this pin has a square pad, the rest are oval. That's also an additional signifier on the board that that's pin 1. But one way or another, you'll be able to tell. Pin 1 will be marked with like a white laser marking on here or a divot, as is shown here. Now, the way they ship these parts, the leads are usually spread a little farther apart than what will fit in the board. It may kind of just fit, it may not. What I tend to do is I put it in here and just kind of give just the littlest bit of pressure with my fingers. So I'll have all the leads on one side, so it's kind of tilted like this. All the leads on one side are in the board. Then I'll grab it with 2 fingers and I'll very just gently, ever so slightly, you barely have to do this, I'll ever so slightly push it over and it'll fall down into place. Okay, so this is good. I wanted to get to the point where we've got a part that's kind of hard to solder in. So this happens. This happens in rework. It happens when you build things out of order, like what we did here. So there are a number of tricks that you can play to deal with this. If I just take this board and put it flush like this, that IC may just fall right out of the bottom. Very good chance it won't sit flush. I can tell it wouldn't. So you want to hold it flush while you're soldering it. One trick would just be to have a piece of cloth or something you can put under here and just press down, and that'll push up against it. That'll probably work for you pretty well. What I tend to do is, in a case like this, I can touch this part while I solder it. It won't get too hot on me if I get in and out. So I'm going to put my finger kind of on the left side here of this part, and then I'm going to flip it over. I'm going to hold this in place. I'm going to solder on the other side, the right side. So I've got a little bit of time before that heat makes its way over to my finger. Now what I'm going to do is I'm holding this part with one hand. On the back with my thumb, I'm going to hold some solder in place near that lead. And then I'm going to come in, I'm going to swipe across over with the solder iron and solder that in place. Let's see, I'll try to get it down where you can see it in focus there, okay? So make sure that solder's sitting flat. I've got about as much solder as I think I need. I'm going to just swipe right along there onto that lead, see it reflow, and boom. So drop that down, maybe you can see it a little bit better. And now that's nice and flush. Looks great. There it is right there. All right, so that's one trick. You can hold it on one side and then use your thumb to hold solder on the back side in order to get that joint to take. Okay, so I'm going to do the same thing now on the other side. Actually, looks like the component's holding down on its own quite nicely. So now I can just solder it in place. We'll just double check one last time. I got my pin orientation correct. It's a lot easier to fix now, a lot more difficult to fix later when this thing is all soldered in place. You have to use some special tools or clip it out and replace it or something like that. Okay, so got that in place. These joints could use a little more solder, but they are going to be fine. They could use a little more solder for visual appearances, for my taste. I may hit them one more time, just clean them up a little bit. All right, I'm going to set the other IC in here. So same thing, I've got it kind of tilted a little. The leads are a little bit wider than the holes on the circuit board. So I put it in, just very gently push it over a touch. And it drops right in. Okay, checking the orientation for pin 1. I see the divot up top where it belongs. Now I'm going to hold it in on the other side with my index finger while I solder on the back. So I got this little bit of solder there. I'm going to just swoop along there and boom, done. So do that a few times, you'll get pretty good at it. It's tricky. There are some parts, where your finger's against it, and the part's going to get very hot very quickly while you solder. Those can be a little more tricky. I'll put something between my index finger and the part, a piece of rubber maybe. That'll give me plenty of time to work. Frequently run into that. I could have a board that has, a bunch of test point places for test points to solder in, but I won't solder them all in ahead of time. I'll just solder them in as I come across something I'm trying to debug, and I want access to that test point. So there may be 10 or 20 test points on a board, but I really only end up needing 1 or 2 of them, so I'll just wait to do them when I need them. Okay, so look at this. That looks okay. Pretty happy with that. All right, so let's see. I think this is the last part. We've got this one integrated circuit left. So same thing. This is that, it's 74 HC148. So same thing. There's a divot on the top of that silk screen to indicate where pin 1 is. This package has that same divot, so it aligns with that. Just going to push it over the slightest bit, and it should drop right in. I'm going to give this one a little more of a push. And you may even find that you might have to take these, and if it's more extreme, you might have to even kind of push them in a little bit with your fingers. You can do that and give it just a little bit of a bend, or bring them a little closer together, make it easier. Some people prefer to do that. I prefer to do this. And when you do that, especially if you had to bend it a little more aggressively, take a look at the leads afterwards. Make sure they're going through there nicely. The one didn't get bent or kinked or something like that. That can very easily happen if you have to do that pretty aggressively. This part needed enough flex to fit in the board that it's holding itself in place just fine. So I don't need to hold it with my finger. I can just solder it. Okay. Now that's soldered in place. Everything looks pretty good. So we've got all our components on here. If we plug this in and turn it on, it should just work. So let's see. Is that the case? All right. Hey, looks like it just works. So I've got, yeah, great. So I can take my potentiometer, it's turned all the way, I'll call it up, clockwise. As I rotate it counterclockwise, I can see each bit turn on. On the 7-level indicator, and then the binary numbers count up as they should. So hey, looks like it worked. If you want to know more about how this works, there is a theory video, so you can go back to the Knox Makers Electronics Wiki and you can look at that, learn a little more about how it works. If you need to debug it, if this doesn't work, there's not a lot to go wrong here. Not much, these components aren't going to be damaged by a little bit of extra heat with a solder iron or anything like that. So if something isn't working, with a resistor divider, the first thing I would do, let me zoom out a little here, is I would take your voltmeter, touch one side, the black side to ground, so turn it on, black side to ground. You should be getting this LED on. If not, there's something just right here with the switch and these resistors and that diode. That should work. Once that works, if you're getting your 5 volts or 4.9 or so on the board, you can put your multimeter one side on ground, the other side on 5 volts. You'll see your 4.9 to 5 volts. You should put it on VREF. You should see the 4.096, about 4.1 volts from that IC. If not, then there's something with these resistors and that IC there. They need to touch up the solder joints, make sure the IC is oriented correctly. If you're getting your 4.1 volts here, then you should be able to go down this resistor divider and measure the top of each of these resistors. The top of the second resistor should be 0.512 volts. The top of the second resistor should be this 1.024 volts. So you should be able to go up there and measure each of these voltages off each of those and see that all those are soldered in properly. If that's working, that's pretty good. So next, these capacitors probably don't matter, but you can make sure they're on there properly. Then with the ICs, you can just make sure that all your solder joints are good, that there's no solder joints being bridged. So you could easily have too much solder in here and bridge across two of these, and that could cause a problem. So that's an easy thing to check for. But if you're getting good voltage down this string, you've got your ICs in there, you're getting power here, you're seeing power there, this thing should be working up to the point of getting these LEDs lighting up one after another. Should be good there. Then the last part of it is the binary coding part of it. What you should see with that is these should just work. If not, same thing, I would check the solder joints on that integrated circuit. Are there any solder bridges across the different pins on the back? If so, fix those. If not, you should be good there. Pin 1 orientation is a divot on the top where it should be. There's no solder bridge across the capacitor or anything like that. Then the indicators should be lighting up. You know, if the LEDs are not oriented, if they're oriented properly, you can check that by checking the flat of the LED against the silk screen here. So you should be able to check that, and you should be able to just check into the resistor joints. So that's about it. There's not a huge amount to it. There aren't a lot of components to mix up or get in the wrong positions. Just a few components that need to be oriented properly, but they're straightforward to inspect at this point if anything doesn't look right. So that should do it. Hopefully it's all working. If not, bring it in Tuesday night. Someone will help you fix it up. And then go enjoy the theory of operation video to learn more about how this works. So thanks. I hope you had a good time putting this kit together.